celestial sphere? Well, as an observer on Earth, if you look at the night sky, you will see that it appears as a huge dome or sort of inverted hemisphere. Now, this inverted hemisphere could be a part of big sphere surrounding the Earth, and of course, at any time you don't see full sphere. You will not be able to see full sphere any time. We can consider that Earth is at the center of a such sphere. Well, we are having this concept because this is a very useful as a navigator, and our prime concern is the angular distances or angular measurement. We deal with angular distances. So we should also know that this linear distance will not be affected by the angle subtended at Earth by 2 points or 2 planes. For example, these are 2 planes or 2 points, and this star is here or this star is here. If they are at the same plane, the angle subtended at Earth or observer will remain same. So each body in the sky is at different distance from Earth. This fact, of course, can be neglected. Earth and celestial sphere are concentric, and all celestial bodies appear to be projected inside the sphere. Earth is at the center of such a sphere. Well, let's talk about something about distances. The distance between Earth and Sun is negligible compared with that between solar system and the star. The nearest star to Earth is Proxima Centauri, 4.2 light years. That means the distance covered by light in a year is a light year, that is the unit. So it will take 4.2 light years, that is the distance. And this is the star which is seen by a space telescope. And we are talking about the nearest star only. So it is irrelevant whether Sun is at the center or Earth is at the center of the universe. We choose Earth as a center of celestial sphere because this is convenient and the radius of this sphere is infinite. To measure the apparent motion of body on celestial sphere, first we should know how to express its position at any given time. And the position measured is the same technique as it is measured on the Earth's surface, that is angular distances from a reference plane. This is how we measure distances on the Earth's surface. Suppose this is a point here and this one is the equator. So we take this angle and this is called latitude, and suppose this one is the prime meridian. From here this will be the longitude. The first plane of reference, that is definitely is equator projected on the celestial sphere. We can say the equator is a stretch. Suppose this was the equator here and it has been stretched like this. It is called equinoctial. The equinoctial and the equator will have the same plane, and well, this will be a great circle. Great circle is the circle which passes through the center of a sphere. Now let us discuss about the first plane of reference. This is the equator projected on the celestial sphere. It is similar to this measurement, where on the Earth we have the first reference plane as equator and we measure a latitude. Similarly here will have equinoctial, which is the projection of equator. Well, equinoctial and equator will have the same plane, and this is a great circle, which simply mean that this circle passes through the center of the sphere. Now let's discuss about the poles of equinoctial. Well, we have poles on the Earth's surface. If we produce this poles of the Earth's surface, they will meet somewhere here on the sphere, on the celestial sphere. These are called poles of equinoctial or celestial poles, and as the Earth rotates on its axis, it will appear as the Earth sphere is rotating about the Earth in opposite direction. Only the poles will appear stationary. So here the Earth is rotating in this direction. The celestial sphere will appear to be rotating in opposite direction. That is how it will appear rotating this way if seen from northern hemisphere. Since Earth is rotating west to east, it will appear rotating from east to west. Now we can have these reference that the line joining north celestial pole and south celestial pole will be called celestial meridians. Basically, these are the semi-great circles, or we can say the half great circle. They are joining poles, and of course, if this is one meridian, the other half of the circle will make other meridian. So now this is the high time to define first coordinate, that is a declination, which is similar to latitude. Well, the declination is the angular distance of a point on the sphere, that is celestial sphere, north or south of the equator. So this is the angle at the center or arc of celestial meridian. Well, this is the arc, and this is the arc of celestial meridian or angle at the center of celestial sphere or angle at the center of Earth between equinoctial. Well, this one is equinoctial, and this one is the parallel of a declination. The arc of celestial meridian is contained between the equinoctial and the point considered, and this declination is named 0 to 90 degree north or 0 to 90 degree south, similar to latitude. Well, all points on this parallel of declination, all points on this parallel of declination will have the same value of a declination. The declination on celestial sphere is equivalent to latitude on the Earth's surface. So here it is the center, C is the center of the Earth or center of the celestial sphere, since both the spheres are concentric. And if we join this line and with the celestial body, suppose the celestial body is here, so wherever it meets the Earth's surface, that means this point is called geographical position. And we can define geographical position where a line joining the celestial body to the center of Earth cuts or meet the surface of Earth.